Hello, so today what we'd like to do is we'd like to review on quadratics. So let's try to get started here, starting from number 46. So what are the sum and product of the roots of the equation here? If you remember, the sum formula is negative b over a, and then product is equal to c over a. So knowing that, let's try to apply that here. Sum must be, negative is part of the formula already, b value here is negative 4. So negative 4 becomes simply positive 4. Over a was 6, so we end up getting 2/3. Now, then which one has sum as 2/3? Only possible answer would have been choice 2. Let's see if the product is negative 2 or not. Product is equal to c, which is negative 12, over a, which is equal to 6. Yes, indeed, we get negative 2 as the answer. Number 47. Once again, they want us to find the sum and product. Sum is equal to negative b, which is 11, over a, which is equal to 5. Product simply is equal to negative c, which is negative 3, over a, which is equal to 5. Number 48. Sum of the roots is equal to negative 3. Now, if the sum is equal to negative 3, then s will be equal to negative 3. Now, in other words, I can put this one over 1. Now, in other words, if a is equal to 1, then we get to realize that b must be equal to not negative 3, but 3, because you see, sum has the negative sign already within the formula, so b would have been equal to simply 3. Now, how about product? Once again, 2 can be written as 2 over 1, so if a is equal to 1, then c will be equal to 2. So we end up getting 1, 3, 2 as the coefficient. We see 1, 3, 2, but this one has to be negative, so it's not the correct answer. In fact, 2 was the most popular wrong answer. In fact, the answer is choice 3. It's the ratio of this one is 2 to 6 to 4, which is same as 1 to 3 to 2. Alright, let's move on to the next question. Number 49. Sum is equal to 3 over 4. So in fact, if in this case, if I were to rewrite this one as 4 as my value of a, for example, and you can see that here in all 4 choices. Now, then sum is equal to 3 over 4. In other words, negative b over 4. Now then you will realize that here, by comparison, 3 must be equal to negative b. Then by multiplying by negative sign, b must be equal to negative 3. So that's why we get to realize here, b is equal to negative 3. How about c? Product then is equal to negative 2. In other words, if the denominator is equal to 4, the numerator must be equal to negative 8. You see, negative 8 over 4 is equal to 2. So in case a is equal to 4, then c would have been equal to negative 8. So 4, negative 3, negative 8 should be my coefficients, which is choice 3. Number 50. Sum is equal to 9 over 4. Once again, if our a value is equal to 4, now, then notice that b is not 9 but negative 9. You see, sum, and then the b has negative opposite signs given that a is positive. How about c? C would have been equal to simply 3. So 4, negative 9, and 3, which will be choice 3. Alright, let's look at number 51. Write a quadratic equation such that the sum of each root is 6. So sum is equal to 6. That means I can put it over 6 over 1. Then if a is equal to 1, then negative b will be equal to 6. In other words, if a is equal to 1, then b would have been equal to negative 6. That's the opposite sign. How about c? C comes from the product, which is negative 27. I'm going to just put it over 1. That means c over a. Since a is equal to 1, then c must be equal to negative 27. Then our equation would have been x squared minus 6x minus 27 equals to 0. This is one of the many possible answers. Number 52. Let's try to factor this one completely. When you look into this one, I realize that x is common. Alright? Now here we have 6 minus x squared minus x is what we end up getting. Now, but when you look through this one carefully, you will realize that x squared is in the middle and then has a negative coefficient. What if you had to have a positive coefficient? That means factoring out these negative signs. So instead of factoring out x, what if I had to factor out negative x? Then I would have had a negative 6, positive x squared, and positive x, changing the sign, all three of them. Now, secondly, if you have to rearrange this one with the x squared being in the front, then it might be a bit more familiar for us to look at. Now, how about now? Yes, you can factor this one, can't you? So we end up getting x plus 3 and x minus 2. That becomes our trinomial given. Then this makes choice 4 as our answer. Number 53. Let us factor completely. Then here once again you will realize that 2x squared is common. Then here we have 6x squared plus 5x and minus 6. I just wrote down 2x squared first. Now, which 2 makes 6x squared? One option is x and 6x, or another option would be 2x and 3x. So why don't I just use 2x and 3x? Now, negative 6, how can you make negative 6? We could have 1 and 6 or 2 and 3. Now, what if I just use 2 and 3? If it's wrong, then we just have to change it. And in this case, how do we check it? By looking at inside and inside and outside and outside. So inside and inside, you get 6x. Outside also, you get 6x. By adding or subtracting, can we somehow get 5x? The answer is no. So this is in the wrong place. So what if I was to erase these? And then I rewrite maybe 3 and then 2. And this becomes 9x, and then outside becomes 4x. Haha, how can I get 5x? That's right, if this becomes negated, in other words, this one has to be negated to make the negative 4x, which makes the other one to be positive. And that becomes our complete factoring. So we end up getting choice 4 once again. Alright, let's look at number 54. If you have to factor this one completely, you'll realize the a is common factor. And here we have 10x squared minus 23x minus 5. Now, in fact, this is factorable one more time, but how can you factor it? Think about factors of 10 and factors of 5 somehow creating 23. 23 is very close to 25. In other words, what if I have 5x and 2x? And 5 times 5 makes 25, and then 1 makes 2. In other words, if you want to check this one once again, inside and inside becomes 2x, outside becomes 25x. How can I get negative 23x? That means this one has to be negated. That means this one has to be negated, which makes this one to be positive. Alright, so this becomes our answer. Let's move on to number 55. Once again, factor this one completely. What do you see to be common? That's right, 3 is common. And t to the how many? 4 is also common. Then here, from our first term, we end up getting 4t to the 4th. Now minus from second term, we'll end up getting 25 because 75 divided by 3 becomes 25. And that's it because we factor out the entire t to the 4th power. But you will realize that this one is not done because 3t to the 4th is okay, but this is a difference of perfect squares. So what is square root of 2t to the 4th? Yes, 2t squared plus 5, and then 2t squared minus 5. And that becomes our answer. Alright, let's look at number 56. One way which we can do this is factoring by grouping. So what we are used to is having 3 terms, but now we have 4 terms. What can we do? One thing which we can do is we can separate them by groups of 2 by 2 as an example. We could have done 3 by 1, but here we have done 2 by 2. Then you will realize that x squared is common here. So we have x plus 3 if you have to factor out x squared from both terms, here we can factor out negative 4. That means we have x plus 3. Aha, wait a minute. X plus 3 is common in both cases. And if you have to factor these two things out, x plus 3, we are left with x squared minus 4. Now, what is x squared minus 4 once you factor? Yes, that's right. X plus 3 was already there. X squared minus 4 is what? X plus 2 and x minus 2. And which one of them is our answer? Choice 2. That's right. That becomes our answer. Let's look at number 57. Find the roots of the equation. So what are we going to do? We can use the quadratic formula. X equals negative 7 plus or minus b squared, which is equal to 49, minus 4 times a, which is equal to 2, and times c becomes negative 3, all over 2 times 2 becomes 4. In other words, here we have negative 7 plus or minus square root of, this is 49, and then this value becomes 24. So in fact, 73 all over 4. That becomes our answer, which is choice 3. Alright, let's move on to number 58. Same idea, how we're going to get it. In order for us to use the quadratic formula, we have to subtract 9 first and set one side of the equation equal to 0. So y squared minus 3y minus 9 equals to 0. And what are we going to do? Y must be equal to negation of b, which is simply 3, which I'll just set these, this one is out, plus or minus square root of, we end up getting 9 minus 4, a is 1, and then c is equal to negative 9, all over 2. That means 3 plus or minus square root of, here we get 45 all over 2. In other words, 3 plus or minus 3 radical 5 over 2. That becomes our answer, which is choice 4. Alright, let's look at number 59. How do you know the characteristic of root? Yes, that's right, you are right. We have to use the discriminant, negative b squared minus 4ac. Let's try to plug it in and see what we end up getting. B was negative 10, so negative 10 squared minus 4 times a, which is equal to 1. C is equal to 25. Then you will realize that this becomes 100 minus 100. In other words, this becomes 0. When discriminant is equal to 0, what do you realize? That's right. When discriminant is equal to 0, that means the roots are equal. That's what it means, real, rational, and equal, which would have been choice 3. Now, let's look at number 60. Once again, how are we going to know the characteristic of the root? By discriminant. So b squared, which means 3 squared, minus 4a, which is equal to 9, c also, which is equal to negative 4. Now then, let's see what we end up getting. 9. Here we have plus 144, which is greater than 0, obviously. Now, when you combine them together, it's not a perfect square. So therefore, what we end up getting is, since it's not a perfect square, irrational number, which is choice 4. Number 61. They want us to use the discriminant to determine all values of k that will make this equation having equal roots. What does it mean by equal roots? b squared minus 4ac has to be equal to 0. Let's try to apply that and see what we end up getting. B squared in this case becomes negative k squared minus 4 times a, which is equal to 1. C, which is equal to 4, is equal to 0. Then here we have k squared minus 16 is equal to 0, which makes k, gonna rewrite it here, then k plus 4 and k minus 4 will be equal to 0. That allows to k have negative 4, and then k is equal to 4 as your answer. We have two of them. Alright, let's continue. Number 62. So when we are trying to do completing the square, yes, first step is adding 11 so that you can get rid of this term. Once you have 2 first term, what is missing here? That comes from having the middle coefficient, which is 7 divided by 2, which is 7 over 2, and then square it. So if you square this one, we get 49 over 4. So that becomes our answer, 49 over 4, which is choice 2. That's basically the value which you would have added to complete the square. Alright, let's look at number 63. Once again, they want us to solve this one by completing the square. Then, once again, I'll bring this one in, so we get x squared minus 6x plus 2 is equal to 0. Now, to get rid of 2, we have to subtract 2 from both sides. Then we get x squared minus 6x must be equal to negative 2. Which number would you need? Yeah, that's right. We're going to divide this one by 2 and then square it. That means plus 9 on each side. Then here on the left side, we end up getting x minus 3 squared. On the right side, we get 7. To get rid of the square, we have to take the square root. Then x minus 3, in fact, is equal to plus or minus square root of 7. How can I have x by itself? By adding 3, therefore, x equals 3 plus or minus square root of 7. But what the question was asking for was this step. X minus 3 squared equals 7, which is choice 2. Alright, let's look at number 64. Here, when you have leading coefficient that's not equal to 1, what we want to do is we want to divide by that. Then we end up getting x squared minus 6x plus 2 is equal to 0. And once again, we're going to subtract 2 from both sides. We get x squared minus 6x equals negative 2. Which number can I add? Yes, I can add 9 because that's the half of negative 60, and then square it becomes 9. So we're going to add 9 on both sides. Then here on the left side, we end up getting the x minus 3 is 3 squared. That's what we end up getting. On the right side, we end up getting 7. So to get rid of the square, we end up getting x minus 3 is equal to plus or minus square root of 7. To have x alone, we have to add 3. Then x equals 3 plus or minus square root of 7. That becomes our final answer. Alright, number 65. How'd you graph this one? In fact, if I were to rewrite this one, y will be greater than or equal to x squared minus x minus 6. Then you will realize the y-intercept of this graph would have been at negative 6. That must be y-intercept. Where do I see negative 6? It would have been first two of number 1 and number 3. Well, all of them seem to have negative 6 as the y-intercept. Then, since y is greater than the equation, then we realize that something above the value. So we are looking at choice 1 and 2. That those are the shaded areas are the ones that's above the parabola. Now, then if you're to set it, if for example, if you're to set this one equal to 0, borrowing the idea from the equation, then you will realize that x minus 3 and x plus 2 is equal to 0. That means x would have been equal to 3 and then or negative 2. So 3 and negative 2, which is choice 1. Second one has negative 3 and then positive 2, but it would have been first choice. That becomes our answer. Number 66. How do you solve this one? First, what you want to do is assume an equation x squared minus 3x equals to 10. And by bringing over 10, we end up getting x squared minus 3x minus 10 is equal to 0. Then how do you get this one? When we do the factoring, we get x minus 5 x plus 2 is equal to 0. That makes x to be equal to 5 and then negative 2. So then when we with these two values, what we're going to be doing is we'll be checking upon each section. Let's say this is negative 2 and then this is 5. which number can I plug in here to show that this is greater than 10? What if I have to put negative 3? Let x equals negative 3. Then here we get left side is equal to 0, right side is equal to 10. Left side is no greater than 10, so therefore this one is rejected. Between these two, which number is good? 0. Alright. Oh, actually, never mind. For the first one, when you plug in negative 3 doesn't give you 0. Sorry about that. When you plug in negative 3, then we get 9 minus 3 times negative 3. Is that greater than 0? So here, then we end up getting 18, so that section is okay. Between negative 2 and 5, we can plug in 0, for example. Then our left side is equal to 0, which is not greater than 10. So therefore, middle section is out. How about the section on top of it? We can let x equals maybe 10. Then you will realize that 10 squared minus 3 times 10 is greater than 10. So here on the left side, we end up getting 70. Is 70 greater than 10? Yes, it is. So that becomes our answer. So here we have, since we're not including the borderline, open circle this way, open circle that way. That becomes our answer. X has to be greater than 5, which is this one, less than negative 2, which is choice 3. That becomes our final answer. Number 67, same kind of idea. Let's try to finish this one. Here we get by subtracting 5, or I can assume, so x squared minus 4x minus 5 is greater than 0. How about that? Now this becomes x minus 5, x plus 1 has to be greater than 0. And let's try to do the test point. So here we have 5 and negative 1, which will make the left side equal to 5. Now, then what I'm looking for is point less than negative 1. What if I were to use negative 2? And when I plug in, this becomes 4, and this becomes positive 8. 4 plus 8 becomes 13. Is definitely greater than 5. So this section is okay. Between these two, what if we select 0, for example? That means 0 is greater than 5. Nope, this section is cancelled. How about above 5? What if I were to use 10? Then 10 is used here, which makes 100 minus 40, which is equal to 60. Is 60 greater than 5? Yes, it is. So our answer is this one. Alright, that becomes our answer, number 67. Number 68. How do you find the values of x and y? Since both of them are solved for y, what we can say is 3x minus 6 must be equal to x squared minus x minus 6. Bring everything onto one side, we get 0 equals x squared minus 4x is equal to 0. Alright, that means by factoring x and then x minus 4. So here, x will be equal to 0, and x minus 4 will be equal to 0. That makes x minus 4 means x has to be equal to 4, and y is still equal to 0. So 0 and 4 is my answer, which is choice 2. Okay, here comes the last question. How do you solve this one algebraically? Unlike before, since y is equal to each other, in this case we have to solve for y, then you will realize that y must be equal to 5 plus x. In other words, when you see y, which is right over here, you can give 5 plus x in place of y. Then let's see what we end up getting. 4x squared minus 17x plus 5 plus x plus 4. Then, if you combine them together, 4x squared is equal to negative 16x when you combine these two, and then we have plus 9. Bring everything onto one side, we get 4x squared plus 16x minus 9 is equal to 0. I know that it will be difficult, but if you had to factor this one, we would have gotten 2x, and to make 16, we have to add 9 and then subtract 1. And we end up getting inside and inside becomes negative 2x, outside and outside becomes 18x. 18x minus 2x becomes 16x, which works correctly. So here, then x, to find out x, we end up getting 2x minus 1 is equal to 0. In other words, 2x is equal to 1, where x equals 1/2. How about here? 2x plus 9 must be equal to 0. That means x must be equal to negative 9/2. Now then, when x equals 1/2 and or when x equals negative 9/2, what would be the value of y? We can find that from here. So, when x equals 1/2, what happened to y? Y must be equal to 5 plus 1/2, which will be equal to 11/2. How about here? Y is equal to 5 minus 9/2. Then once you do this one, you'll realize that we end up getting 1/2. So our final answer becomes 1/2 when x equals 1/2, y equals 11/2. And when x equals negative 9/2, y is equal to 1/2. Alright, that's it. We'll stop here and have a great day. Bye-bye.